Hello, my name is Adam Faskowitz, and I will be giving a tutorial on how to use TIBCO's Wafer Map Pattern Recognition dashboard. So the purpose of this dashboard is to allow users to be able to find patterns within their wafer data, be able to create models that are going to be able to recognize those patterns, and be able to deploy those models on future data. So the dashboard is split into the following pages. There's an upload data tab. There's a generate patterns where you're going to be doing the selecting of specific wafers and putting them into pattern groups. Then you're going to create models that are going to recognize the specific patterns on the create models page. Then you're going to be able to upload new data and score new data from the models that you've created. Additionally, there are some bonus pages that kind of go more into the technical details of your data, but I'll get to those later. So, and then again, these are the packages that you need here on the bottom when you download this dashboard. So I will click Get Started. So on this upload data page, this is where you're going to be uploading your own data into the dashboard and configuring it so it's going to be able to be used in this dashboard. So here in the top left, we have the instructions for uploading new data. I will go through this quickly. So you make sure that you're on the Your Uploaded Data data table. You're going to click on this left node, click Replace, and just pick the new data from your local files. So once you've done that, you can get out of the data canvas here, and now we can move on to this formatting your data section. And this is essentially just matching up the column names that refer to specific parts of the data, like the lot, wafer ID, etc. Then there's this more mathy technical detail of SVD components. Basically what this is, SVD is a method that we use that decomposes the wafer data into a smaller number of variables that can capture the whole picture of each wafer. So doing this, in most cases, you want to just keep this as low, but if you have more complex data or you might have a lot of patterns within your data, then you can move this to medium and high. But I would first recommend just starting it when it's on low. Then once you're ready, all you have to do is click the Load Data button or continue with default data if you're just trying to play around with the existing data. And please be patient if this does take a while if you have larger data sets. So I'm going to click Continue with Default Data. So what you see here on this page, this is where most of the magic is happening and where a lot of the user interaction takes place. On the left side of the screen, you're dealing with your raw wafer data. On the bottom left, these are all of your wafer maps, where on the top left, these are clusters of your wafer data. So these are pre-generated through our data pipeline. And what these clusters are groups of similarly looking wafers. So it'll be able to detect this through our algorithms and be able to find these groups that'll give you basically a good head start into finding the patterns that you're interested in. So you see now here on the right side, this is where this library of patterns is. So these are some patterns that have been created, this ring pattern, this moon pattern. And in here, you can select on one of these wafer maps on the top right, and I'll show you every single wafer that is in this specific pattern. And this is just like an average view of all of these wafers. So additional notes here in this middle panel, you can change the number of clusters. So if there are more or less patterns in your data, you can change this number. And then these middle panels, this is how you're going to add wafers from the left side to the right side, basically creating these groups or patterns. In addition, you have the ability to remove wafers from pattern. So let me just demonstrate how you would be able to create a specific pattern. So let's say I go here to this one cluster because I find it interesting. Selecting it will then filter to only wafers within that cluster on the bottom left. You can see that this maybe resembles something like a heart. So you go to this add wafers to new pattern panel. You type in heart, make sure to click enter there, and then click the add to new pattern button. And after doing so, you'll see that the heart pattern is now on the right side of the screen with the other patterns that have been created. And you can see all of the wafers that are in that pattern that we just put in there. So if you now want to demonstrate how we can add wafers to existing patterns, I might also look at this cluster number 48. We can see that these also do look like hearts. So if I wanted to just take a couple of these, for example, and add them to the heart pattern, all you got to do is go to the middle panel here, add wafers to existing pattern, click add to existing pattern, and now you can see that they have been added. It's gone from 12 to 14 wafers. So in addition, like I said before, we could take one out too if we thought it didn't look like a heart for some reason. And then you also have the ability to remove the entire pattern. But I will undo this because it looks like a legitimate pattern. So I think that's everything on this page. Once you are satisfied with all the patterns that have been created, you can just click this bottom button, continue to modeling, to move on to the modeling phase. Okay. So now that we're on the modeling page, let me just explain a little bit how this is going to work. So you're going to go to the top left and you're going to select a target pattern. So doing so, I'll click on this heart pattern from before. So what this is doing, you're creating a random forest machine learning model that's going to be able to learn on the pattern in the wafers that you had selected on the previous page, and be able to create a model that's going to be able to recognize those on future data. So the way this process works, all you have to do is just click this Run Model button, and it'll be able to train on this wafer data and then evaluate it on your whole data set. So the classification threshold here is 0.1. And what that means is that with a 10% confidence value, the model will identify the wafer as a heart. So it's pretty low here. It's usually 0.5 for most normal random forests. But the reason why we do 0.1 here is because we want to find as many heart patterns as possible. If you have a lot of data, you could miss a lot of them that you hadn't seen on the previous page because that takes a lot of manual work. So what you do here is if you lower it to 0.1, you can basically find things that the model missed, or find things that you missed that the model was able to find. And that could be very valuable. So the way that you're going to evaluate your model is here in the top right, there's this confusion matrix. And in this confusion matrix, the way you can interpret this is here on the horizontal axis, you could say, these are things that are predicted, that the model predicted as either a pattern or not a pattern. Whereas the vertical axis here, these are things that are actually in our data set, so things that we selected as a pattern or not a pattern. So if I were to click on the bottom right here, these are true positives. So things are the model predicted the pattern and that I picked to be a pattern. And you can see that these are exactly the same wafers as these. So now that doesn't give us so much information, but what really does is this bottom left section of the confusion matrix. And why this is great is because these are false positives or things that the model predicted to be a pattern, but that we didn't find on the last page. And why this could be good is it's able to show the model might think that you might have missed something on the previous page. And doing that, you could see that that's true. So a lot of these do look like the heart pattern. So the way this is going to work, what you could do is you can edit the model results. And this is something that's really cool on this page is that, okay, I found something that the model did wrong. So I'm going to take the things that should have been hearts, click add wafers to target group here on the bottom. And doing that, now we've increased the number of examples that the model has to learn on for recognizing this heart pattern. And you can see that here, this doesn't really look like our heart pattern, but that is okay because we want to see as many false positives as possible, because once we're done, this is kind of just a iterative step to help the model become its best version of itself, but we are fine with mistakes in this portion. So what I'm going to do now is I'm going to hit run model again. So doing this is kind of the iterative process of this whole thing. So now that the model has more examples of the heart pattern, it will now hopefully become a little bit more accurate. So you can see those metrics went up a little bit, but you can see that there still are more false positives. So all you simply have to do is you just go into this panel here and do what you did before. Click add to wafers to new target group and hit run model again. So here we can kind of see that the accuracy is increasing because there become less and less things that the model are uncertain about. So you can see that the accuracy, the metrics are way up here, and there's only 2 false positives. One that doesn't really look like a heart and one that does. So I'm going to add this one heart and add it to the wafer group. And I'm finally going to run the model one last time. And hopefully we could see results that are a lot better. So after doing this, know that the classification threshold here, so we can see that these false positives both don't look like hearts. So it seems like we're satisfied and we're good to go, and we don't need to add any more hearts. Now, the classification threshold, we can move it back up to 5 to demonstrate this and click run model again. And now the model shouldn't miss anything. It should be basically good to go. Now, something to note though is, when you save this model, you actually don't have to move this classification threshold back up, because what the classification threshold does, it's essentially a good way for you to view the confidence scores and view what the model got wrong, but it's not attached to the model. This is just something that is a separate thing to help you find where the model went wrong. So once you're done with this process and you feel confident about the results, you click Save Model. Now it'll save it to your local folder, local path, and you're good to go. So now you can just go through all the other patterns that you want to be able to recognize on, and you can move on to the next step. So here, if you just go to the bottom and click Upload New Data, this is essentially similar to the page from before. So you follow the same steps of replacing the data and making sure that the column names are matched, and then you could just click Load New Data. But again, I'll just click Continue with default data here. So this is some new data that we're going to look at. So on this page, the bottom here is all of your new data. This is similar to from before of what the patterns and the composite views are going to look like. They're going to be here. This is a lot trend for each pattern and the wafers per pattern. So where you're going to actually really start here is you're going to start setting things up from the panel on the left. So after you've uploaded your data, you can filter it by lot and what you want to evaluate on. So I'm just going to evaluate it on both the lots that we have here, 3 and 4. Then you can select the specific models or specific patterns that you want to model on. And if you don't see anything here, you can click a refresh list of models, and that will be able to hopefully update with any new models that you've created, maybe on the Create Models page. So once you've done that, you now just click Run Models on New Data. And after we've hit Run Models on New Data, we can see that this top portion has been populated. So you can see that this is a chart that shows the count of how many hearts are in the new data that the model classified as such. If you click on it, you can see everything in the new data that the model classified as a heart. Here you can click on moon, ring, etc. And here you can see the lot trends. You can see that there's more moons maybe in lot 3 rather than lot 4. And another thing that you could do here is you can adjust the confidence interval that you want to have for each of these models. So if I actually were to lower it to 0.1, you see that these counts have changed because you required less confidence for something to be able to be classified as a heart. So these look like mistakes, but it could be a nice exploratory tool when you want to lower the needed confidence to find a certain pattern. In addition, you can change this so that you only look at wafers that the model was really confident on. You can see that that lowers the amount dramatically, but that could be also something that could be valuable. So these are things that you can kind of just play around with on this page. And I believe that is it here. So now I'll move on to just a couple of the bonus pages. So this is the Explore SVD Modes page. This is more technical, but this is saying that, so we split the wafer data into a complex data pipeline, and you can now basically represent a wafer by a linear combination of 10 variables. So this is what these look like, which means so one wafer is a combination of a certain amount of this mode, a certain amount of this mode, a certain amount of this mode to be able to create, one wafer like this. So doing that, you can kind of get some interesting insights from this page because you could see like what the most, so they're also sorted by the amount of importance each mode has. So this carries the most weight, which makes sense. It's kind of just a little bit of value across the whole wafer map. But here you can see that it kind of looks like the heart pattern that we picked before, or at least it resembles somewhat of a heart shape. So it's interesting that that is one of the most important factors in creating one of these wafer maps. So this is just a little bit of exploring on this one page. Now I'll move on to the composite pattern test page. And on this page, this is where we can compare our actual patterns that we tagged from earlier, along with the composite wafer maps that we saw on this page. I'm actually going to lower this back down to 0.5 so we could see all of the patterns. So looking at them side by side, you can see if there are any dramatic differences or if they look basically the same. You probably want them to resemble each other or else something might be off a little bit. But you can see that they all pretty much look consistent with each other. So things should be good. So I believe I've reached the end of the tutorial. Thank you for watching, and be sure to check out our dashboard. Thank you.